Hi there and welcome to Hegarty Maths. It's Mr. Arnold here, and in this video we're going to be looking at coordinate geometry of the line 1. This is based around the core maths modules at A level but is applicable to most other maths modules. Okie doke, let's crack on and just do a very brief GCSE recap of certain things that you should hopefully remember. First thing is that the equation of a line is given by the formula y equals mx plus c. So let me just do a very brief sketch of what's going on here. So suppose we have an axis like so, and we have some line y equals mx plus c. M is the, well actually let's start with c. The c value is the gradient. So c is the not the gradient of the line, I beg your pardon. It's the y-intercept. Y-intercept. In other words, where it crosses the y-axis. So this point here is the point. It's going to have a x value of 0 because it's on the y-axis, and the y value, the y coordinate, is going to be some value c. So that's what the c tells us. And then the other value is going to be, let me just get a different type of line here, so we get a dotted line for this and a wee bit thinner. M is what we know as the gradient. So for every 1 unit I travel across to the right, I should travel m units up. So m, the value m, is the gradient of the line. Another word for gradient in Ireland, we call it the slope. Over here is the gradient. The gradient, or as I would normally refer to it as the slope. Okay, so that's briefly what you should remember from GCSE. But also at A level, sometimes linear equations can be written in this form, or what we call the general form, and that's ax plus by plus c equals 0. And that is where a, b, and c are all integers. So are all elements of z, which is integers, and integers are positive or negative whole numbers. So a, b, and c are positive or negative whole numbers. If it's written like this, it's still the equation of a line, but that's the general form of the equation of a line. If I want to convert this into this, what we need to do is change the subject. And if I want to go backwards, again, we will just change the subject of the formula. Okay, so let's try some examples here. Example 1. I'm asked to find the gradient and the y-intercept for each line. So this should be fairly straightforward. Just a very brief recap here. So the gradient, denoted m, is going to be equal to the coefficient, or the number in front of the x value here. In this case, it's -1. There's a 1 here, so it's -1. The gradient is -1. It's sloping down like so. And c, the y-intercept, must be equal to 6. So this is y equals mx plus c. M is -1, c is 6. Let's have a look at the next one. The gradient m must be equal to -2, so the coefficient of x, and the constant at the end is the y-intercept. So c equals -3/5. Just in case, the y-intercept as well can be given as a point, I suppose. So the point for the y-intercept, where it crosses the y-axis, is going to be 0, 6. And in this example here, it's going to be 0 and -3/5. So fairly straightforward there. Okay, let's have a look at a slightly more complex version. So again, I need to find the gradient and the y-intercept for each line. First thing I'm going to do is get them in the form y equals mx plus c. So if I get them in this form, it's very, very easy to read off the gradient and y-intercept. So I'm going to change the subject here. Okay, I need to isolate y, get y on its own on the left hand side. So the first thing I'm going to do is I'm going to take 3x off both sides equals negative 3x. Then I'm going to add 2 to both sides. 3y equals negative 3x plus 2. And then finally I'm going to divide both sides by 3. So y will equal negative x. Negative 3x divided by 3 is negative x. And then rather than trying to write this down as a decimal, much easier, keep it as a fraction, 2 over 3. So we divided everything by 3. Hence, I can read off that the gradient is the gradient m must be equal to negative 1, the coefficient of x, and c must be equal to 2 over 3, which means that the intercept, the point where it crosses the y-axis, is 0 and 2 over 3. Okay, let's have a look at example B here. You may want to have a go at this one yourself. You could pause the video now if you want, and then play it once you're finished. First thing I'm going to do, change the subject again. So I'm going to take 4x off both sides. So negative 5y plus 1 equals negative 4x. You might do this slightly quicker. I'm going to subtract 1 from both sides. Negative 5y equals negative 4x minus 1. And then I'm going to divide both sides by negative 5. I want a positive y here. So divide both sides by negative 5 and we get y equals, well, this is negative and I'm going to divide it by a negative number, so my answer will be positive. And 4 divided by 5 I can write as 4 over 5. So 4 over 5x. Again, a negative number divided by a negative number is going to give me a positive result, and 1 divided by 5 I can easily write as 1/5. Hence, I can say that the gradient m must be equal to 4/5, the coefficient of x. C must be equal to 1/5. Hence, the intercept, the y-intercept, must be the point 0 and 1 over 5. Okay, so a couple more important facts we need to remember from GCSE. And one of them is that the value of the x-coordinate on the y-axis is always 0, and the value of the y-coordinate on the x-axis is always 0. So we've already met this idea in the previous example, because the y-intercept was always 0, c. So the x-coordinate was always 0 on the y-axis. But if I wanted the x-intercept, if you will, I know that the y-coordinate must be 0 and the x-coordinate could be anything. Let's just call it, in this case, z. Not important, that z, by the way. Don't get too attached to that. And another very important fact is that parallel lines have equal gradients. Now I'm going to very briefly demonstrate this using my favorite website. So I'm just going to show you a couple of parallel lines. So suppose I do the line y equals 3x plus 1. We can see it there. I'm going to do a line with the same gradient, y equals 3x, and let's do another one underneath just for good measure, y equals 3x minus 4. Now I'm going to zoom out quite a bit here, and you can see that all three lines are all parallel. The reason for that is that they all have the same gradient. So parallel lines have equal gradients. That's an important fact. Okay, let's try some examples now. Example 3. I want to find the coordinates of the points where this line meets the axes. So I need the x-intercept and the y-intercept. So remember, the x-intercept what happens at the x-intercept? Well, that implies that the y value is equal to 0. So what I can do is substitute y back into the function. So we get 2x plus 4 times 0 subtract 3 is equal to 0, which implies that 2x subtract 3 is equal to 0, which implies that 2x equals 3, adding 3 to both sides, and then dividing both sides by 2. So x equals 3 over 2. So one of the points is the point 3 over 2. When x is 3 over 2, y is 0. And now let's go on and get the x-intercept. Sorry, not the x-intercept, the y-intercept. And remember, at the y-intercept, on the y-axis, the x-coordinate is equal to 0. So, we end up with 2 times 0 plus 4 times y, subtract 3 must be equal to 0, which means that 4y subtract 3 equals 0. Do my little implies sign here. I'm going to add 3 to both sides. So 4y equals 3, and then finally divide both sides by 4. So we get 3 over 4. So when x is 0, when x is 0, y is 3 over 4. Okay, I'm just going to modify this slide a wee bit so that we can see everything a bit better. Okay, let's move on now. Example 4. A line is parallel to 6x plus 3y subtract 2 equals 0 and passes through the point 0, 3. We're asked to find the equation of the line. Well, the important fact here is that we're talking about a parallel line, which means that it has an equal gradient to this line. It's got an equal gradient to this line here. So I'm going to change the subject and work out what the gradient m might be. So let's write it down. 6x plus 3y subtract 2 equals 0. So remember, we're getting it in the form y equals mx plus c. I'm going to subtract 6x from both sides. Then I'm going to add 2. 6x negative 6x plus 2, and then finally divide both sides by 3. So y equals negative 2x plus 2 over 3. So we're dividing everything by 3 here. So if the gradient of our old line was negative 2, the gradient of the line that we're looking for, so let's write this down. The gradient of the line we are working towards also equals negative 2 because it's parallel. And if you look carefully here, I can see the x coordinate is 0 in this new line. So that means the y coordinate is 3, the y-intercept is given. So this value here is where it crosses the y-axis, or the y-intercept. So that means the equation of the line equation, EQU for equation of the line. Let's write it in the form y equals mx plus c. So it's y equals negative 2x, and the c value here is 3. So plus 3. A fairly straightforward question there. Okay, on we go. Another important fact. The gradient of a line is given by m equals y2 minus y1 over x2 minus x1. So I'll briefly demonstrate this idea here. If I just sketch a axis very quickly, and suppose we have some line like so. If I was to call this point here x1, y1, and call this point here x2, y2, how might I work out the gradient? Well, if we remember, it's the change in y over the change in x. So let's just see where this formula is coming from. We get a dashed line, a wee bit smaller. Okay, so if we go the gradient of the line, the change in y over the change in x. So the first thing I'm looking at is the change in y. Well, this point here at the bottom of my little triangle would be the point x2, y1, because it's absolutely in line with this point here. So the y value will be the same, whereas here it's in line with this point, so the x value will be the same. So this distance here is y2 minus y1. And in a similar fashion, this distance here, this dotted distance here, must be x2, so this point, the value of the x at this point, subtract the value of the x at this point will give me the distance, so x2 minus x1. And that's the origin of this formula here, y2 minus y1 over x2 minus x1. Absolutely imperative. You must know this for the exam. So make sure that you learn it off by heart, that you write it on a post-it, stick it on your wall so that you see it every single day, because if you don't know this formula, it can be quite tricky to answer certain questions. So make sure you know it off by heart. Similarly, you need to understand y equals mx plus c and ax plus by plus c equals 0. You need to know all those off by heart. They are not given in a formula book. Okay, so let's try and apply this knowledge now to a question. So if I look at example 5 here, the first one, I'm asked to find the gradient of the line for each pair of points. Now, what I always tell my students to do when you're given a question such as this, or when you're doing coordinate geometry, it's very important and very helpful if you label the points. So I'm going to call this x1, y1, sorry. I'm labeling the points x1, y1, and here this can be x2, y2. And then what we do is just apply the formula. And a good way to remember the formula is always to write down the formula first. So y2 minus y1 over x2 minus x1. So that means that m equals, and what we're going to do now is substitute the values in. So y2 is negative 7. y2 is negative 7. Subtract y1, which is 5, over x2, which is negative 5. Subtract x1, which is 4. Negative 7, subtract 5 is negative 12. And negative 5 subtract 4 is negative 9. And let's tidy that up. It's a negative number divided by a negative number is going to be positive, and 12 over 9 can be simplified. If I divide top and bottom by 3, we get 4 over 3. Let's take a look at the second one here. Same approach, label the points, x1, y1, x2, y2. Going to use the same formula. So m is going to be equal to y2 over here, 3d, minus y1, which is negative 5d. You might notice I put brackets around the negative 5 just in case, over x2, 6d, minus x1, 2d, tidy up the top, that should be a 3d. 3d subtract negative 5d is 3d plus 5d, which is 8d, and 6d subtract 2d is 4d. And then I can actually divide top and bottom by 4d and get a gradient of 2. Okay, example 6, final example. The line with points 3, negative 4 and negative t and 2t has a gradient of negative 3. We're asked to work out the value of t. Well, as I said before, when you're doing any sort of question like this, it helps to write out the equation or the formula, because you will remember it if you write it out every time. M equals y2 minus y1 over x2 minus x1. Okay, let's see what we can fill in first. I'm going to label the points x1, y1, x2, y2. So let's substitute. Oh, we can see that the gradient m is 3, so let's label that as well. M is negative 3. So m is negative 3. y2 is 2t. So 2t subtract y1, which is negative 4. Negative 4 over x2, which is negative t, subtract x1, which is 3. Right. Now what I'm going to do is multiply both sides by negative t subtract 3. So we get negative 3 on the left hand side times the negative t subtract 3, and on the right hand side we still have 2t. I'm going to tidy this up. I'm subtracting a negative number, which is the same as just adding that number. Expand out this bracket here. 3t plus 9 equals 2t plus 4. And now it's just a simple equation. Take 2t from both sides. Equals 4. And then finally subtract 9 from both sides. So t equals negative 5. Negative 5. There we go. Okay, now I'll just wrap up with one last comment. It has absolutely no impact on the question if you were to decide that you're going to call this x2 and this y2 and this x1 and this y1. If you follow the same method, you will end up with the same answer. So ultimately, it doesn't matter which way you label them, so long as you are consistent in what you do. That's all for this video. Hopefully you found it useful. I'll be back again with another one soon. All the best with the revision, and take it easy.